books you call cathode anode. In physics, what happen? Let me use collector and emitter, because I'm going to change the polarity here also. So I'm going to connect now the positive terminal to the collector and the negative terminal to the emitter. Then how the electric field inside this? In every numerical, you just show this E bar. This is very important. Now the E bar, who will produce this E bar? Who will produce this E bar? E bar will be produced by the external source. In every numerical, just show this E bar. Now, any electron which is present here. So let's take some arbitrary electron. Any electron which is present here, in what direction it will have kinetic energy K. Then along with that, electrostatic force also will act, no? Along with that, electrostatic force will act. So what will happen to these electrons now? Shall I say they'll get accelerated? They'll get accelerated. So if I go for plotting graph, numericals will be very easy for you. Only the theoretical idea is very important. That also. Now, when applied potential difference is 0, that is what this V I'll call it. So there should be some current. There should be some current. Then as I increase potential difference, the E will increase. And because of electrostatic field increasing, then what should happen to kinetic energy of the photoelectrons that are ejected with zero kinetic energy, with non-zero kinetic energy, and they'll get accelerated, no? So shall I say that current will increase? Now you have to justify, so why the curve your so we have to give explanation for different parts of the curve. So first, why this is because at zero potential there must be some current. Okay, that is what this current is. And then I kept intensity constant. Capital I is what? Intensity here. Capital I is what? The intensity. Then lambda is also fixed here. And then as I increase the potential difference here, the current through the galvanometer or through this emitter, it will increase. So we have to give explanation for this part of the graph. Okay, this one. We'll give name like O, A, B, C, and D. Now, why AB current will increase? Any reason for that? So it's quite very simple. Has the increased potential difference, electrostatic field will increase. Now earlier, in the absence of applied voltage, only those photoelectrons which are having non-zero kinetic energy, they are able to reach the collector. What about the space charged layer? The space charged layer was at rest. So that one. So now, as I apply the potential difference, look at here now. This electrostatic field will exert a force on the space charge on the electrons. So these electrons, earlier they were at rest, they'll experience a force, electrostatic force. Due to electrostatic force, what happen? These electrons, they'll start migrating towards collector. In the absence of potential difference here, only non-zero kinetic energy photoelectrons were striking the collector. Am I right? Then now, because of potential difference applied, the electrostatic field will be non-zero between in the gap. This electrostatic field will exert a force on electrons in the space charge layer. The space charge layers electrons now they'll experience a force. The space charge layer electrons they'll experience a force. So due to this force, the electrons also start now accelerating towards the collector. They also start drifting towards the collector. So what should happen to now? Number of electrons striking the collector will increase. And we know current is what? Rate of flow of charge. So the amount of charge flowing through the emitter will increase in a given time. So current will increase there. So therefore, the graph will be like this here. So from ABC, what we can say here now. From ABC, what we can say, the current is continuously increasing. Why? The space charge layer starts melting or diminishing. Any reason for that? The electrostatic field, what happen? What it will do? It will start pulling that electrons from the space charge layer towards the collector. So the number of electrons striking the collector increases. So therefore, the current should increase here. I didn't increase intensity. I think you should be clear. What is the intensity of light at this point? Same. What is the intensity of light at this point? Same. Number of photons incident is constant. Number of photoelectrons ejected is constant. But number of electrons striking the collector depends upon this applied potential difference. Any reason? The zero kinetic energy photoelectrons will be attached. The electrostatic field will accelerate it. Then they'll start moving towards collector. So therefore, current should increase here. So any reason for ABC we should write? For this part of the curve, what is the expression? You can write it here. The space charge layer, the photoelectrons in space charged layer experiences electric force QE due to applied PD from the cell. Okay, this one. Hence, they start moving towards the anode or towards the collector. So what will happen now? Number of electrons. Now number of electrons. The number of photoelectrons striking the collector increases. Hence current I increases as PD across the cell increases. Okay, fine. So there's a one reason is what I'm putting here now. Look at the explanation what I'm putting here, this one. Very good conceptual questions will ask you. That's why I'm just putting that information here. So now in the region ABC, what shall I say? Shall I put one thing? The will diminish. So from A to BC also it will increase, and then from CD what it's a constant. You can see like a CD it will remain constant here. So we'll put some straight line. And now this will be constant. And now we have to explain the graph CD. Why afterwards it will be constant. CD is a straight line. ABC is a curve ABC. No, straight line CD. So now a constant current starts flowing here. This will call it as high saturation. Okay, fine. No, so that a current got saturated means okay, fine. A constant current flows after that one. What is capital I? Capital I is intensity, small I is current. Please do try to understand the symbols because they are very important here. No. Why the current remains constant afterwards? Though potential is increased, the current will remain constant. Any reason for that? As I keep on increase the potential difference across the cell, that one, the electrostatic field will increase. Then what happen? The space charge layers what happen? Will be pulled out. The electrons from space charge will pulled out and they'll be pushed towards collector. Then at certain potential here, you can say at certain potential, the electrostatic field is so high that any photoelectron that is ejected, whether zero or maximum or k, any photoelectron that is ejected, immediately it will be swept towards collector. Immediately, I'm telling this one. The moment the photoelectron comes here, ejected by this collector, it will be swept by the towards collector. The moment photoelectron is ejected by emitter, no, it will be swept towards collector because the electrostatic field is acting so high that uh, immediately it will be swept here. So therefore, now what will happen to number of electrons striking the anode? Because there won't be any time given for this electron to settle here only. Zero kinetic energy photoelectron. The moment photoelectron ejected zero kinetic energy, it will not take rest here. The electrostatic field will immediately will sweep it towards collector. So what happened to now? Number of electrons striking the collector will be constant. So a constant current flows. We'll call this as I saturation. So getting this, so in the region ABC, the space charge that diminishes. Afterwards, what happened? Any photoelectron that is ejected from the emitter will be immediately swept towards the collector. So therefore, number of photoelectrons striking the collector remains constant. So what is the explanation we should give? Because of higher PD, potential difference it is a PD across cell, any photoelectron, any ejected photoelectron will be immediately swept towards collector. No space charge layer no space charge layer. The photoelectrons are not permitted to form a space charge layer. No space charge layer exists now here. So any photoelectron ejected, any ejected photoelectron will be immediately swept towards collector. Now earlier with zero potential, which photoelectron were able to reach only non-zero kinetic energy. Zero kinetic energy photoelectron, they will be at rest nearby the emitter plate. But here at this particular potential difference, all the ejected photoelectrons will be swept towards the collector. So because of this, what happens? Number of photoelectrons striking the collector is constant per unit time. So therefore, the current will be constant. So I'll put it the number of photoelectrons striking the collector remains constant. So therefore, a constant current flows in circuit. That constant current is what we call I saturation. Anybody how to calculate that I saturation? That I saturation depends on what? Number of photoelectrons. Number of photoelectrons depends on what? The intensity. Intensity. So any formula I should generate for saturation current? So will there be any formula for saturation current? Can we generate any formula for that saturation current? Because what is this current? Current should be rate of flow of charge. Anybody, can we generate, or it's only not possible? Practically only we can measure, so theoretically there's no such formula. High saturation, practically we can measure. The emitter will tell how much of that one. So here what we do is the I saturation formula is the current. This should be equal to, this called as quantum efficiency. What is eta? Called as quantum efficiency, hc by I'll write it here. Okay, now so from where you are bringing, how you are bringing this? What is eta? Eta is called as quantum efficiency. From where I'm bringing this, I'm not going to do anything very big. How many photons emitted by source? Depends on what? How many photons are emitted by source per second? Power of source by energy of photon. Power of source is what? PE. Power of source is what? I'll write it PS. Power of source. Let me use symbol PS here. PS. Okay, fine. This is by energy of photon. What is energy of photon? SC by lambda. Yesterday, I think previous class I just discussed. Energy of photon, power of source by energy of photon will give number of photons emitted by source per second. Then, is it for every photon one electron generated? I think already I gave explanation yesterday. Some of the photons will interact with electrons, some of electrons, they fail to come out. So therefore, there is some sort of efficiency there. For every 10 to the power of 6 photons, one electron will be generated. One photoelectron will be generated. So that is what called as quantum efficiency. So with that, what will happen? We'll get this one. So all these are per second, no? Shall we put anything charge or only this much here? So I think some charge should be added, no? Charge of electron. What is this all? PS by SC lambda, number of photons. Eta into PS lambda SC will become number of photoelectrons ejected into charge of electron will become saturation current. Do remember, I don't know, in books they have missed it very badly. So, but in numericals, we need this one. The saturation current depends on these particular quantities. Lambda is incident wavelength, power of source, HC are constant, and eta depends on material and is a charge of electron. Okay, I agree this. So this is saturation current. Okay, now about this one. Now what I do is like, I will, now I'll reverse the polarity. If I reverse the polarity across the cell, mean the positive terminal instead of connecting to collector, the negative terminal I'll connect to collector. Then what conditions will arise, we'll see.